Hi everyone and welcome to this new video in which I continue my Linux Privilege Escalation series. This video will be the first of a short subsection of the course in which we focus on the enumeration aspect. So, when it comes to privilege escalation, the first step before using the exploitation techniques that we already saw, the first step is actually enumeration. It is to extract the information on the remote system. Once you are able to extract information, once you have enough information, the right information, then you can use the specific exploitation technique to obtain a proper privilege escalation. So we're going to talk about system enumeration, cron job enumeration, and the enumeration of capabilities in these three videos, of which this is the first. So in this video specifically, we will introduce the concept of enumeration and we will ask why is enumeration so important. Then we ask ourselves, okay, suppose you are on a Linux system, because this is the Linux privilege escalation series, what should we enumerate? Then we will see how to enumerate with specific bash commands. These do not cover 100% all of the things, but are the main sources of enumeration, so the most critical and important things to know. And finally, we will talk about automated scripts, how to use them, where to find them, and things of the sort. And in the practical section, how to enumerate, where we will see some actual commands, we will perform them on an Ubuntu installation. So this is a virtual machine running Ubuntu. We will show all the different commands, how to use them, how to read and interpret the relative outputs. So I hope the video is interesting. If it is, please leave some feedback, share this video with like-minded people, subscribe to my channel to help me grow and support me, and that's it. You can now enjoy the video. So we start off with a question. Why is enumeration important? Asking the why question is really fundamental to understand. Okay, we have to learn about system enumeration, but why do we have to do this? Why do we have to spend effort and time to learn this? Well, the idea is that once you obtain a reverse shell into a Linux system, such as a Ubuntu machine, for example, the first thing you need to do is enumeration. Now, what is enumeration? Enumeration is all about gathering meaningful information regarding the system you are dealing with. So, in a given system, you will have a lot of different variables, a lot of different things to consider in the picture, and enumeration is about creating the picture, is about painting the picture. A proper enumeration procedure will allow you to understand the specific configurations being deployed on the system that you are interacting with, and more importantly, what are the vulnerable aspects of the system. Why? Because everything that is deployed on a digital system, such as a Linux distribution, can be either secure or not secure. This means that once we have all the information, once we have the picture, we can start to analyze it in order to obtain the security vulnerabilities, in order to understand what are the parts of the system that potentially could be exploited, that potentially could give us a way to privilege escalation. Now, once you understand the vulnerabilities, you can then go to the next step and try to think about exploiting them. Of course, the road from vulnerability to exploit is not always simple. I would say it's really rarely simple. Most of the time it's very hard and time consuming. However, this is the only way. This is the way to go. You start from a vulnerability and then you understand how you can exploit it. So the second step, going from vulnerabilities to exploitation, we already covered some exploitation techniques in the previous videos. However, we did not talk too much about enumeration, and so this video will focus on enumeration and also the following two videos. So this is why enumeration is key. Enumeration is the first step to gather information. This information, of course, have to be meaningful, meaning that we don't want to just look at random information in a random order without any structure. We want to look at specific things in the system in a specific way with a specific methodologies so that we understand much faster and much better what are the vulnerabilities. So this is important. So the next question is perfect. Okay, but what do we need to enumerate? And in this question, the idea is, what is a modern operating system running a Linux distribution made of? What are the components? Because each component, each part of the system could be vulnerable. So what are the main components? First of all, we find the underlying hardware architecture. So this specifically means, for example, the CPU in usage. What kind of CPU? Sometimes there are vulnerabilities that affect directly the CPU. Now, these vulnerabilities are not really easy to exploit, but to understand a system, we must always start with what kind of processor is it running, what architecture in particular, what architecture, for example, is it an x86 or x64, is it Intel, is it ARM, is it another architecture, so on and so forth, and then the model, the specific model that implements that architecture, like the latest Intel processor, the latest AMD processor, and so on and so forth. So all things with the hardware. Of course, our hardware enumeration will be pretty simple. We are mainly interested in the CPU architecture. And this is critical because, for example, if you want to run an exploit, you need to understand well what is the hardware architecture, because you need to compile the exploit with the appropriate version so that it runs on the CPU you are dealing with, if it's 32 or 64 and so on and so forth. Then, going forward, is the software. And specifically with the software, the first thing we need to think about is the kernel version. These are all Linux distribution. After all, we are doing a Linux privilege escalation, so all our machines, we can assume, are running the Linux operating system, so the Linux operating system. Now, Linux is an open source kernel that is developed by the community, and specifically, every Linux kernel has a specific version, and there are vulnerabilities that affects only specific kernel versions with specific kernel configurations. So actually, here it would be kernel version plus configuration. However, to understand easily the configuration is not too easy. So to simplify our life, we are mainly interested in the kernel version. You also have to think about configuration, but it's only more nuanced and more complex. For now, just focus on the kernel version and you will be good. And the next step in this group of 3 elements is the Linux distribution version. Why? Because on top of the kernel, on top of the Linux kernel, there are actually distributions built on top, which offer a lot of software. For example, here we have the kernel, and then we can have Ubuntu, we can have Arch Linux, we can have Kali Linux, and so on and so forth. Actually, there is an hierarchy of distribution, each of which builds on top of others, so it's like pretty complex. So the idea is that sometimes vulnerabilities arise because a certain distribution, like Ubuntu, packaged a software in a vulnerable way. So the vulnerability is only found in specific distributions. And this is why another thing that we want to enumerate is what is the Linux distribution plus its version. For example, we are running Ubuntu version 2004. This is an example. So these first 3 sets of things are like the overall configuration of the system. Hardware you're running with, kernel you're running with, and distribution you're using. Then we have some kind of configuration about users and systems. We start off with the users and the groups. So what are the users of the machine? What are the groups of the machine? And this can be easily enumerated using the etc passwd file. Then we understand if we have access to powerful groups, which means, okay, but my user, for example, who am I among all the users? What are my privileges as the user Leo or as the user whatever? And then we can check, okay, let's check the groups we belong with. Do we belong to powerful groups? And here, when I say powerful groups, it means groups that typically have access to specific command that can be used to do privilege escalation. An example is the Docker group. If you are part of the Docker group, you have access to the Docker command, and you can use the Docker command to perform a privilege escalation. So this is really important. There are other groups of the follow of the sort. So in general, enumerating the groups you belong to is really key. Another aspect of enumeration, of course, is the sudo configuration. This can be done with the command sudo-l. And of course, it works only if either you have the password or sudo is configured to not ask you for a password. So sometimes it works even without password, other times you need to have the password of your user to use it. Either way, a good try on sudo L is always useful to do, so understanding how sudo is configured essentially. Continuing, we have to enumerate all the file system directories. Of course, here, in general, it's hard to tell exactly a priori where you will find the useful stuff, where you will find the useful files. But typically, you have to try to enumerate, for example, all the home directories you have access to, this is key, all the OPT directory, because sometimes there are extra binaries, extra file, backup files and things of the sort, and also the var www html, which contains the root directory for web servers if you're running Nginx or Apache, stuff like that. So these are like the expose content towards the internet using the web protocol. There are other directories, you can enumerate the temp directories and so on and so forth. In general, be careful of the file system, you might find interesting stuff. Then another thing regarding the file system are the binaries with special permissions, and in particular with the setuid and getuid like bit on. So I already discussed about this kind of configuration and how you can exploit vulnerable SUID binaries. And specifically, there exist commands that I will show later on to enumerate only the binaries that have these permissions. So this is extremely useful. Because if you find a binary with a SUID configuration, then you can ask yourself, wait a second, is this binary vulnerable? If it is, there you have it, a privilege escalation. So always consider those stuff. Then another important thing is the local services. So what's the idea here? Sometimes a server exposes two types of services. So given a service, this service can either be local or public. And here the distinction I make between local and public is the public service is accessible by anyone who has an internet connection. Consider, for example, a web server that exposes a WordPress, and anyone who goes to the correct domain will have access to that WordPress. So in this case, the WordPress listens to the public 443 port, which is the HTTPS protocol. So this is the port for the HTTPS protocol. So this is a type of public service. You do not need a special position in the network to access this service. Anyone in the internet, in the public internet, can access it. Other times, however, you have services that are configured to listen only on local interfaces. So for example, you might have a development server or a debug server or an internal service of any kind, but this service only listens in the local host interface, like 127.0.0.1 at a given port, say 3000, whatever. And maybe this service is used by developers who first have to access the machine, and then they can access the service. Typically, this kind of access is also done through SSH tunneling. So this is a key technique that later on I will show in the channel outside of the context of this series. But the idea is that you can have services which listen locally, and it's a key thing to enumerate them. And this brings me to the next point, enumerate all the network interfaces. Why? Because sometimes the use of a server is not really direct, meaning that the service itself, the server itself, does not contain useful information or useful data. However, it is connected to internal network interfaces that are not exposed to the public internet. At that point, in those situations, the server becomes an extremely useful pivot point. So the server becomes a pivot that we must learn how to use. And to understand this, we must enumerate all the network interfaces to understand if we have access to internal networks, what type of networks, and what are the host exposed in those network interfaces. So this is extremely useful. So this in terms of networking. Then of course we can enumerate all the software installed with the relative versions. So for example, if there is a vulnerable version of a known software, then we can exploit it. We can enumerate for backup or saved sessions. Sometimes certain programs save sessions in files, like Tmux is a great example. So if you use Tmux, which is a terminal multiplexer, sometimes it happens that the developers or developer operations, they leave out the saved session files, and you can just access them and you can restore the environment that was running previously. Then you have, for example, repositories that are under version control systems. Now, when you have a repository that is running with Git or SVN or other sort of version control system, the useful thing is to understand that we do not only have access to the latest version of the repository, but since it's running under Git, we have access to the entire history. So sometimes what happens is that we're able to go back in time and access secrets that were later removed, like password, access tokens, secrets of any kind. So it is very useful. Once you find a Git repository, go back in time, check the logs, check for suspicious stuff. Always useful to keep an eye out for. And finally, these two things, which I will discuss in later videos, which are cron job and capabilities. Now, these two topics, I will make a specific video for each one of them, for cron jobs and capabilities, so I will not discuss them now, but to make it short, cron jobs are periodic tasks that are executed on the system, while capabilities are another way in which permissions can be handed over to binaries to do specific activities, and you can exploit both of those stuff to perform a privilege escalation. Okay, another thing that I didn't say here, but I put it later, is to enumerate environmental variables. So environmental variables, so variables of the environment of your shell. So this is key. Now, is this 100% all you need? Of course not, but this covers the major classes of findings that you will find in a real system, which means that typically what happens is that either you can exploit the kernel, or you can exploit a specific configuration of user and groups, or some secret was exposed in the environmental variables. You can exploit sudo. You find a specific binary or a backup or something that does not have the right permission. You find a SUID or GUID binary. You find a local service that runs with a misconfigured configuration. You find a network interface that puts you in a pivotal position inside the network, or you find a software with a given CVE, you find some backups, you find a repository and you explore that, or you find a cron job, or you explore some capabilities. So typically, this is the idea. Of course, in each of those sections, things can get quite complex. For example, you can have a CV for a software that is really, really hard to exploit. But if you do these steps, if you enumerate all this information, then you will be able to understand what you need to do privilege escalation in most of the cases. And so now we can proceed on, okay, perfect. How do we enumerate this stuff? Okay, so now I just mentioned the various classes of things that you should look for. Now I'm gonna actually bring commands to get this information out of a system. And to showcase this, here I have a reverse shell that I just spawned in the Ubuntu. So this is the Ubuntu machine, and here is the command that I use to spawn the reverse. We don't want to do it through the VM interface because I just want to show how it looks like from an attacker point of view. This is how it looks like. So here we have a reverse shell. The first thing I suggest is just to improve the shell with a simple Python 3 c import pty.spawn bin bash. So string here bin bash. So now we have, and here I have to actually, so here I did something wrong. I have to retake the reverse shell, my bad. So it's Python 3 -c import pty spawn bin bash with a single quote here, and then I close the thing. And now I have a better shell. So clear, and it clears. So the first thing to look for hardware architecture, we can get it with the command uname a. I do uname a, I get a bunch of information here, and in particular, So you name A. In particular, what we see is, so we see that we have an x86-64 processor. So this is the type of processor that is running. So that's the architecture. So we are x86-64. So this is a 64-bit machine. Then if you want the kernel version, look, it's already here. It's this Linux PC 5.15.0-117 generic. So this is the kernel version. To just get the kernel version, you can do uname-r. And here you get the kernel version. So this is running a kernel 5.15 and all of this other stuff. Then to get the distribution, you can do uname-a as here. It's written, look, it's Ubuntu here. But to get the actual, it's 20.04.1-Ubuntu. Or you can also use the LSB release-a. So with this, we get the release, the codename for the release, and all the information about the release. So that's good. Another thing we can get is the environmental variables, so the environment variables. So here are all the environment variables with the command env, with the command band. So the command env is used to print out all the environmental variables. And of course, all these commands, by the way, will be available. Link in the description will point to a GitHub repository. So we'll have everything for creating your own personal cheat sheet and stuff like that. So this is really useful because sometimes people hide stuff in the env variable. So it might be useful. Of course, when you spawn a reverse shell, it's harder for critical stuff to be stored in the environmental variable, but sometimes, let's say that you get execution on a web server, then you could have something like precious, you could have something critical, so always check that out. Then we have users and groups. So of course, with the user, with the whoami command, we can get the name for the current for who we are. So for example, in this case, it's the Leo user. Otherwise, we can just do a cut of etc passwd to have a list of all the users in the machine. So these essentially are all the default users, and then I have the special Leo user that I created for this video. Now here, I show another command to create just a text file with just the names of the users. So how do I do this? This is the command with the pipe and the redirect. So the idea is that you do, first of all, a cut, etc passwd, but then we want to cut each line with the separator, with the column separator, and we want to take the first column. So the idea is that the etc passwd has a structure where it has information, then another information, then other information, and the various information are separated by these colon characters, by this dot dot. So the idea is that we cut thanks to that, and then we get the first column, so this one. And this one actually contains the username. So we cut that, and then we put this into a file named users.txt. So this command, we do this command, and then in the users.txt, it's just a file with all the name of the users. And it can be useful to just enumerate this information depending on your system if you do not have too much time. So another thing to do is the groups. So if you do groups, it's gonna give you all the groups that you are currently in. So Leo, ADM, CD-ROM, sudo, deep, plugdev, lpadmin, lxd, samba share. Then if you want to get all the groups in the system, we do cat/etc/groups, actually /group, here without the final S. So once again, we have all this structure information, and we can use the same technique as before to extract just the name of the various groups. How? We can do a cat, etc, group, then we do a cat, another cat. So like this cat is for reading, and this other cat is for cutting out, F1, and then we redirect all the output of this to the file groups.txt. And then we have groups.txt. I mean, if you do not want to create new files, you do not want to trigger maybe an antivirus or something like that, you can just get this without the redirection, and it's just gonna print them in the standard output. So if you do not want to interact with the file system, just do not consider the final redirection. And here groups I already showed to check if we have access to powerful groups. Of course, here the notion of powerful groups is not really specified. It is not my intention to specify it, but essentially some groups have certain capabilities like the Docker group. If you have access to the Docker group, you can create Docker containers, then you can create a Docker container and you can mount the root file system to the Docker container, and you're able to sort of like do a privilege escalation to access root files and things of the sort. So there are ways to use access membership to certain groups to do privilege escalation. Then another thing we can do is the sudo-l. So sometimes the sudo configuration requires you to type a password. Here I'm gonna put the password of the user, a really simple password, I can show it. And now notice that the configuration says that I can essentially do all the commands for all the users. I can impersonate anyone to do anything. This is clearly like vulnerable if we have access to the Leo password. I mean, this just means that the Leo account and the root account are essentially the same. Because if you compromise the Leo account with its password, if you do an account takeover to the Leo account, then you are also essentially root. So this kind of configuration can be just means that the Leo account is the root account. Is it vulnerable? Then it depends how you treat the Leo account. If you are able to obtain the password, then of course you can exploit this and attack this. So I made a specific video on sudo, go check it out on how to exploit it, so I'm not gonna talk about this any further. So this is to enumerate the sudo configuration, pretty simple. Then we have the file system directories. So of course we can use commands such as ls. We can also use the command tree, but I don't think it's installed. So like typically this command is not installed, so I'm not gonna showcase it, but essentially tree allows you to visualize a directory as a tree. Like in my local machine here, if I do a tree/l2, so in this case there's not much, but like look at this. So this is all the material for this current video that I'm recording in a tree structure. It can be extremely useful. The problem, however, is that most of the time this is not already installed, so typically you will not find it. And to install new software, you would need root privileges. So it's not really that useful, but it's another way to explore the file system. Otherwise, you have always ls. It's pretty simple, but also pretty useful. So you have this, so you can do this, you can do in the /home. Of course, in this case, we have all the stuff of the user. For example, a typical pattern is, do you have access to the private SSH keys of a user? Well, if you can read some directory and you see that there is an SSH folder, you can just try to read it. In this case, we can read it because this is our own folder. Of course, there's nothing in it, but we can still read it. So another useful thing to do. Then we can have, for example, var www. Actually, in this case, I guess there is no such file or directory. While as well as var, ls var. So in this case, we do not have the www directory because probably we have no web server, so it was not created. But in general, if you exploit a web server, you will have this directory. It will contain the public exposed files, and it could be useful to explore, maybe to introduce new files, to read the source code of the application, also extremely useful. Then we can enumerate all the SUID and GUID binaries. So the command is find / which is the starting point of the find process. Then we do perm u equal s. This means give me all the binaries that have the SUID permission, and then we do to redirect dev null to redirect the standard error so that we see no errors. We do this because typically, if you don't do this, you will find a lot of not enough permission errors, so you want to skip them. And now we have this list of files. The idea is that this list of files, all these files have the SUID bit permission. For example, the password, of course, it has this permission because it has to allow users to change password. Now, if one of those programs is vulnerable, then we can exploit it. In this case, of course, these are the default SUID binaries, so they are typically pretty safe. If you find a vulnerability here, you have a research, you can obtain a CVE. It's not that trivial, but in general, it's something to look out for. And then you can do the same thing, but instead of doing -perm -u, we do -perm -g to signal, look, I want the SUID binary, but not on the user, but on the groups. So this is called for the GUID binary, the GUID. And same thing with different binaries, of course. For example, this wall. In this case, we have a GUID binary, so the same thing applies. Then to enumerate for local services, we can use the netstat that prints out the current ports listening. So I do netstat with the flags -lpnt. So in this case, it's just gonna print out the local listening interface for the TCP sockets. So in this case, we have a local DNS server and this 631, which honestly, I don't know what's the process that listens on this. Let's do this as root, so we get also the program name. So let's do sudo netstat. So apparently it's capsd. So capsd, I don't know exactly what it is, but it's the program that is listening on this port. This means that if we exploit this, now we know that we have a local service running on this port. The address is the local interface 127.0.0.1 and the port is 631. This is for the TCP socket. For the UDP socket, the command essentially is the same. You just have to change the last flag from T to U. And here is the UDP ports. And with sudo, we also obtain the name of the process. Now notice that without sudo, we do not see the name. This is because to actually read the name, we need permissions, which we only can do with sudo. So an attacker might not be able to understand immediately what is the kind of process. But for example, if you see a local process listening on port 80, on port 22, on port 21, on well-known ports, you can typically expect that this is a well-known process implementing a well-known protocol. And continue with network interface is pretty simple with IP-A, with IP space A. So IP space A, we get all the network interfaces. Look, in this case, it's just two. The local host, which every host has, and then this ENP1S0, which is actually the interface that the virtual machine shares with QEMU. So it is a NAT interface, and so this means that I can interact with the my host, with the QEMU listener, on the address 192.168.122.1. So in this case, this ping I sent to the QEMU in my host running the virtual machine listening. So if there is some kind of vulnerability in that specific component, I could be able to escape from the virtual machine to the external host. Of course, this doesn't really happen. It's not that simple, but it's another thing to consider, the network interfaces. Continuing, we have the software installed with the version. So either we can use which with the name of the software, but of course in this case, we will need to know the name of the software. So this is not really that useful. Then either we can go into the well-known directories where software is installed, like the usr locals bin, usr local bin, usr bin, and you can actually check this by going into the path. So the path environment, a variable in the environment, typically tells you where software is. So you start from this directory, then you can do some ls to enumerate in this case, for example, it doesn't exist here, and it doesn't exist here either, user bin. So user bin exists, we have all this software, and we can understand like the virus version. I mean, this is not really that fast to do, but here we have access to all the software that is installed. Just look for the path and just explore the binaries of the path. You will see a lot of common binaries. Just skip them and go for the binaries that are not that common, that you typically do not see. Continuing, with respect to backup, save session, things of the sort, we can use the command find. So the syntax is similar to the finding of the SUID and GUID binaries, but now we're just gonna do -name with this kind of wildcard that it says, look, any kind of name with this specific extension. So like a backup extension, KDBX extension, for example, this is the extension used in KeePass, in the KeePass password manager, and things of the sort, so this can be really useful. Then if you have a repositories under a version control system, you can do the git log commands, the git checkout, the git switch. This is not a tutorial on Git, maybe I can make it in the future, but the idea is that you can interact as if it's a normal Git directory. This means you can go back in the history and analyze previous comments to check out secrets. And finally, cron jobs and capabilities will be discussed in a later video, so I will not show any specific command here because in later videos I will zoom in specifically on these arguments. And so this covers the main commands that you can use to enumerate a system. Of course, once again, there's much more, but this is a solid base to start off. You do this and you have an understanding of the system you're dealing with. Finally, to finish off the video, I want to talk about automated script. So the idea is that there are also automated scripts that essentially do what I showed and even more in an automatic way. So you don't need to press any command, they just give you the output. So how do you use them? And for example, here I listed the two automatic scripts that I know of. One is linpiece and the other is linenum. Personally, I prefer linpis, but in this video I'm going to show linenum. They are both the same essentially. So the idea is, how do we use them? The first step is in downloading the script in the attacker machine. So you don't want to download it directly in the victim machine. So for example, we can do this wget to download the linenum script. And here, if you do ls linenum, we see the script. We can also read it. It's just bash. It's a lot of bash. It's just 1,300 lines of bash. And look at this. It contains all the stuff about the bug, system, user, environmental, job, networking services, software, interesting file, Docker, container checks, and footer. So just a series of commands. You can also read this file to understand the kind of checks that it makes if you're able to read bash. It's not too complex, just requires some times, but the idea essentially is to automate what I previously discussed. So here is the notes, here is the script, and here is our reverse shell. So once we have downloaded it into our attacker machine, the next step is to transfer it into the victim machine. So we're going to start a local server in the attacker, and then with wget, so here I'm going to get the IP. The IP in this case is, so in this case, this one does not work. So here I drop my shell. I have to get another shell here. I'm just going to do the same, essentially, just going to do the same command here. I have the shell. I'm going to upgrade it. Import pty the spawn bin bash, and like this. No, okay, what did I do wrong? Of course, because it's technically like this, bin bash. Okay, now we have a shell. So the idea is that we do wget with our IP, with the attacker IP, which is 129.168.122.1. The port is 137, is the lead port, and then it's linenum, I think. Okay, it's linenum.sh. So we do this. Notice we got a hit here, and we have successfully downloaded the script. I can make it executable with chmod. Typically, they are not by default. So actually, this one apparently did not read it properly. It's like this. So now it's executable, and then I can execute it. And when I execute it, I can use the T program to make sure that the output is splitted and is written on the standard output and into a file, so I do not lose anything. So I can do with this linenum pipe t and then linenum output.txt. Of course, this name you can decide however you want it. The t command here is used to make sure that the output of the linenum command is printed both on the terminal and also in the txt file. So we executed it, and now it's running the script, it's getting all the information, and it's printing that same information into the txt file so that we can then get it, so we can export it into our machine and analyze it in a better way. So it's very, very useful. So for example, here it says we are a member of the LXD group, could possibly misuse these rights, so stuff like that. And now we have this linenum output. It's a bunch of files and we can just read it. So we can do, actually we can just open here, this linenum output. We can just read it and we have all the output of interest. We can just try to read it, but essentially the idea is that it looks for, so let's try to read it fast. It gets all the information about the releases, about the host name, the groups. Here are all the group membership. Here are all the users. Here are all the environmental variables. The path, information about the path, the shells, the files, and stuff like that. So like the network interfaces here. So essentially most of what I've told you, the processes, okay, so what I forgot here actually, is that other than the install software, of course, another key aspect of enumeration is to enumerate the processes. You can do that with ps aux. Here it doesn't work because the shell is limited. I can improve it, but right now I don't have that much time. So the idea is that, and one last thing regarding the software install are actually the processes. So remember, in the first video of the series, I showed how you can enumerate the process with ps aux, and ps-axjf that shows the hierarchy of processes. So this is also very important to understand. And essentially for now, that's it. So this is the main idea for this video. The automated script, I typically use linpis when I use it, but also linenum can be used. And when it comes to, for example, certification, sometimes you have to be careful of using these automated scripts because this kind of certification, like the OSCP certification, they don't want you to use scripts that automate the exploitation process. So one thing is if you automate only the enumeration process, but another thing is if you also automate the exploitation process. So be careful on the script you use, be careful on what it does, especially if you have to run it in a critical system where you have specific responsibilities, like during a penetration test, but the idea is that these can be useful. The best thing to do would be to actually create your own automated script based on the specific information that you need. These are a starting useful point, then you can add your own and create your own complex automated script to perform to satisfy your own need. So this is it for this video. I hope it was interesting, enjoyable and useful. If it was so, please leave some feedback in the comment, share with like-minded people, subscribe to the channel and to the next video.